Hi everyone, today I'm going to show you how to manually convert an IPv4 address into binary, as well as how to discover the number of hosts on a network or in a subnet. As you may already know, an IP address uniquely identifies a device on the network, which could be on the internet or on a local area network, which is a LAN. We have two types of IP address. We have the IPv4 address and we have the IPv6 address. The IPv6 address came into existence because of the limitations of the IPv4 address, which was limited addressing scheme space. The IPv4 address can further be classified into five classes. We have the class A, B, C, D, and E. You're more likely to come across class A to C because D and E, they've been reserved. D has been reserved for multicasting and class E has been reserved for research, experimental, and military purposes. Now, it's important for you to know that these classes all have default subnet mask and they all have ranges. Now, I was able to look up a page on the internet to get these classes and their subnet mask, their default subnet mask. As you can see, the class A subnet mask has a 255.0.0.0, while a class B has a 255.255.0.0, and class C has a 255.255.255.0. The class A is usually the most common that you'd mostly come across in um, in the wild. Another thing that you should note is that an IPv4 address is a series of 32 bits. Okay, so because humans find it difficult to read binary, um, we they kind of made it easier to understand by grouping these 32 bits into four octets. So each octet will have 8 bits, right? So each octet will have the first octet will have 8 bits, and the second octet will have 8 bits, the third as well as, and the fourth as well will have 8 bits. So let's see how we can convert an IPv4 address into binary. Because we're dealing with binary, we're dealing with one and zeros, and binary means two, right? So because we also have 8 bits in each octet, we also need to like outline this in the sense that we're going to have the first 2, 3, 4, 5, 6, 7, and 8, and we multiply the previous number by 2. So 1 times 2 we get 2, 2 times 2 we get 4, 4 times 2 we get 8, 8 times 2 we get 16, and so on and so forth. So we get to the last 8, which is 128, right? And because we have 4 octets, okay, let me just give an example of an IP address so it's easier to understand. Let's say we have a 192.168.23.7, right, as an example of an IP address. So each octet here that is separated by the dot, we call this dot the dotted decimal notation, and each octet here, when you add them all together, you get 255. So each octet sums up to 255. So what you're going to do to get the binary version of this is to simply come to the table that you have outlined, which is 1 through to 128 using the binary system. So 128 plus, you get 128 here, which is 1, and you get 64 here, which is 1. 128 plus 64 gives you 192, which means the first octet is 128 plus 64. So here we're going to simply put zeros. The next one, 168. 128, we get 128. We get 128 plus 32. I think that's 160, right? So, and we need an 8, which is 1. So the rest will be 0. Okay, so we move on to the next one, which is 23, right? So 23 here is simply, okay, let's see, 116 I'm going to take this out of here. And 1 4 1 2 and 1 1. So here's 16 plus 4 is 20 plus 2 plus 1, that's 23. So the rest is going to be 0 0 0 and 0. So to get the final octet is simply 0 so we have a 1, we have a 1, we have a 1, and we have a 1 here. So this is 4 plus 2, 6 plus 1, 7. So this is the binary conversion of this IP address 192.168. Sorry, it's supposed to be the next line. 168 and 23 and 7. Okay, so likewise, if you have to convert a binary to an IPv4 address, it's simply the same thing as well. You just have to, if you get this like 11000, okay, so they might give you something like 11000 111. So you have 1 2 3 4 5 6 7 8. Okay, so we have 8 bits here. So let's look at it. So we get 128 here, we get 64, and we got a 000 here, and then we get a 421. So it's going to simply be 128 plus 64 plus 4 plus 2 plus 1. That is the first octet here. So the second octet can be something like 111110011. You get the idea, you get the gist, right? Because that's how you do the conversion from binary to an IPv4 address and from an IPv4 address to a binary. So let's move on to subnetting and getting the number of hosts on a network. Since we know that each octet has 8 bits, right, which sums up to 32. To get a -24, to get the -24, the number of hosts on a -24 on the /24, pardon me, on the /24 bit, we're going to simply look at, since this is 8, 16, 24, the rest is 00000. Now we get 8 zeros. Okay, so the 8 zeros are the available spaces that are there, and to do the calculation, all you have to do is take the 8, and because we're dealing with binary, you raise the 8 to a power, you raise the 2 to a power of 8. So we have 2 raised to the power of 8, which is 256. Yeah, and now that we have 256, we have to minus 2 from the 256. The reason why we have to minus 2 from the 256 is because 2 addresses are reserved for: number 1, the network ID, which represents the network, and the broadcast IP address, which is used to reach so here we have 254. The formula is usually written like 2 raised to power of h or whatever, or n, minus 2, or yeah. So if you're looking at the binary, this is usually how you go about it, right? So it's going to be 2 raised to power of whatever available host here, or available bits here, minus 2. So this gives you the available host. Now to get the subnet mask, right? So because we are dealing with a -24, /24, I don't know why I keep saying dash. So it's going to be, and you know our subnet max is usually 255.255.255.0, something along that line, depending on the class range. So here we have 8 bits because we earlier said that this particular octet, a particular octet sums up to 255. So we have 8, we have 16 here, and we have 24 here, right? So because we have completed this, we have 24 here, the remaining here is 0, so which means there is actually nothing in the last octet. So what we do right now is simply just copy this. So it's going to be 255.255.255.0. Now let's try the /27 to see another example, right? So let's say we have 8 here, we have 16 here, we have 24 here, and the last 0 here we have 24 minus 3, because 24 here plus 3 here, which makes it 27. So we're going to be left with 5 bits. So 2 raised to the power of 5, I think that should give us 32, but let's confirm. 2 raised to the power of 5. Okay, so we get 32. So 32 minus 2, we get 30 possibilities of assigning IP addresses, right? So to get this, the subnet mask, like we said, we have the 255.255.255, and the last octet is usually 8 bits, like we said earlier, and it goes like 111, right? And the rest is zeros. So we have 3 ones and 5 zeros. So if we come here to the IP address table, and we look at 128 plus 64 plus 32, we get 224, I think, but let's confirm. 128 plus 64 plus 32, you get 224, right? So here the IP subnet mask is going to be 255.255.255.224. So that's how you get the subnet mask, and the same thing applies to a /30 as well. And like I said, the network ID is usually like the representation of the network. So here is usually the last octet is usually .0, right? And you could have like 192.168. Whatever .0, because that represents the network ID. The broadcast IP is usually the last IP, which is the .255. So whatever IP address comes before it, we have the .255, which is the broadcast IP, because these two, the network ID and the broadcast IP, are reserved, so you don't calculate it. That's why we -2 from the host. So we have the first usable IP address. The first usable IP address is usually a .1, right? .1 at the end. And then the last usable IP address is, in this case right here, we have the 254. So it's as simple as that. You can do the same thing here as well. So it's as simple as getting the IP address and calculating the subnets, the number of hosts in a subnet.